The next reaction we'll look at is a substitution reaction. In a substitution reaction, functional groups are exchanged. In other words, we don't change whether it's saturated or unsaturated. What happens is simply that on a molecule, for example, CCH, H, we might take that hydrogen off and put a chlorine on. So the state of saturation does not change. Alcohols with a halogen, hydrohalogen, so in other words HCl or HF or HBr or HI, produces a haloalkane. There's a process known as hydrolysis where bases or water with a haloalkane will make an alcohol, and haloalkanes will form alkanes. So what you might notice is that many of these things are probably quite reversible again. First, let's take a look at what happens in a substitution reaction. You find that the one substance will come off the molecule. So here's your molecule, and something comes off it, and there's now a vacant space, and something else goes on, and you create a new molecule. That's how a substitution reaction works. So first, let's go to an alcohol becoming a haloalkane. If I take an alcohol and I add a haloalkane to it, I add a hydrohalogen to it, what happens is that the alcohol will come off and the halogen will go on. And then what happens is that that OH group joins with the hydrogen to form water. Substitution, one thing off, something else on. A haloalkane can become an alcohol. So it goes the other way around. If I take a base over here, this Br can come off, the OH goes on, and I land up with potassium bromide as one of the products. I could take a haloalkane, take off those two chlorines in the presence of heat and light, and add hydrogens in their place. So chlorine comes off and hydrogen goes in. Substitution once again. Combustion reactions are the last type of reaction we need to learn about, and what happens there is you add an oxygen either onto an alkane or onto an alcohol or onto alkynes, alkenes. Any hydrocarbon and oxygen will always give me carbon dioxide and water. We all know that hydrocarbons burn as fossil fuels. Your petrol, your oils, your butane gases are all hydrocarbons, and they burn off and they produce carbon dioxide and water. They transfer chemical energy into heat energy, and all of these combustion reactions, burning is exothermic, gives off heat. Let's just watch a reaction over here. So you can see if you put an alkane or an alkene or an alkyne, it actually just burns. In here, we've got ethine, and ethine is highly reactive. And if I bring a flame close to it, what's going to happen is it's going to cause an explosion. So that's an ethine reaction. Here we also have alcohols that might be reacted. The alcohol will burn in oxygen to give carbon dioxide and water. So methanol and oxygen, carbon dioxide and water. Ethanol and oxygen, carbon dioxide and water. And that is why we can use alcohols as fuels. By the way, just if you are looking at that alkyne reaction, when I use this is ethine, and it's also known as acetylene, it is used in welding because of how hot it gets when it burns.